Okay, we're going to look at sigma notation. So this is just a special kind of notation for writing a summation of things. Summation meaning you're going to try and add some terms together. And sigma, that's just a Greek letter that looks like that we use for sum. So when you look at example number 1, they have this notation written. And what happens is that the first part that you see, n equals 1, this is telling you what to start plugging in. And it counts all the way up to 5. So that means we're going to plug in a 1, a 2, a 3, a 4, all the way up to 5. So this is our start plug-in number and our end plug-in number. And what we're plugging into is whatever the expression here. This is kind of the rule or the equation or expression, I mean. That we're following. And so it says down here that we have a lower index and upper index. So that's other words to say our start and our end. And basically tell us the range of integers that we're going to substitute into the expression in order to get the sum. So we want to plug in a 1 first. It's kind of boring because it's just n. So when we plug a 1 in, we get 1. You plug a 2 into that, you get 2. Plug a 3 and you get 3. 4 and you get 4. 5, you get 5. And then again, that sigma thing means add. And so we're going to end up that this will be equal to a 15. So let's see, example number 2. Again, we're starting at a 1 to plug in, and we're going all the way up to 5, but this time we have a different expression to plug in. This is a cubing expression, and so I'm going to have a 1 cubed, and then a 2 cubed, and then a 3 cubed, a 4 cubed, and then a 5 cubed. So when I look at example 3, that one looks just slightly different because now it's saying our start is 3. So we're only going to have to plug in a 3, a 4, and then a 5. So it's only a little part of it. Again, it's still the start though, and our end. For number 4 there, we're still starting with 1 and going to 4, and we're plugging in. So you plug a 1 into here, you'll get a 1. You plug a 2 into there, you get a half. Plug in a 3, you get a third. Plug in a 4, you get a fourth. So that's the meaning, again, of the sigma notation we're going to add. And you could simplify that and come up with the answer to that sum. A couple things to notice, that the variable here with our index matches the variable in the expression. So if we're going to use I, which is a very common number here, it would have I in the expression. Okay, so sometimes our sum has a pattern which enables us to write the sum using that sigma notation. So when we look at this 3 plus 6 plus 9 plus 12 plus all the way to 60, this should look like a very familiar pattern. Now, we've seen in the past a couple of different sequences, the arithmetic sequence and the geometric sequence. So both of these were lists of numbers, and that's going back in time a little bit, all the way back to page 24 or 23 of your handbook. So you could take a look there if you've forgotten what those sequences were. So if you look at this one, it goes 3 and then 6. I mean, it's adding these terms, but this is a familiar list, 3, 6, 9, 12. And so it's going to be adding a 3 every time. Adding 3, adding 3. And so that was actually an arithmetic sequence that we've seen before. Now we're going to look at adding these special sequences together, and these are going to be called series. So this is actually an arithmetic series. And so the difference between the words, you saw sequence and you see series. Sequence is just the list. A series is going to be adding, and we're going to use this, we can use this notation. So it already noted what we just said, that they're multiples of 3, which means adding 3 every time. And so if I want to write the sum, one way to express that is 3n will give us each of these numbers. If I plug a 1 in, I get 3, 2 and I get 6, 3 in, I get 9. And you can see that was my start, and I'm going all the way to 20. So if you look at the last thing I plug in, 3 times that 20 makes the 60. So we have a very nice, simple expression here to show that sum. Okay, you're gonna have a chance to try, so you could pause right now and try and see if you can figure out what these different sums are. And then we're gonna go the reverse way and have some lists or some series, some sequences that are being added together in the next few pages. So first, if you want to pause, that would be great. Okay, so we're back to unpausing, so you should have tried all of these. So again, I'm gonna start by saying this is my starting value and this is my ending value, and this is the expression I'm plugging into. So I plug a 1 in, then I plug a 2 in, a 3 in, a 4 in, a 5 in, and a 6 in. And then it says to simplify the following sum. So if you punch that onto your calculator, you will get 2275. And a reminder on your calculator that if you want to enter something like 5 to the 4th power, you could enter 5 and then there's sometimes a caret button, or there's a 5 and then there's like a XY or YX button where you would enter that 5 and then that button and then 4. Okay, if we move on to part B, we're going to have our start at plugging in 3s and our end is plugging in 7s. This is a little bit more complicated expression, but that's okay. So we're going to get 3 plus 1 over 3 plus 4 plus 1 over 3 plus 5 plus 1 over 3 plus 6 plus 1 over 3 plus 7 plus 1 over 3. So that would be our end plug-in. So we have 4 thirds plus 5 thirds plus 6 thirds. You see that pattern happening, 7 thirds. It's continuing to add a 1 to each of my numerators. And I just really made a mistake here. K is not 3 the whole time, just the first time. So let me go back and fix that. You're like, what is she doing? So erase that, erase that, erase that, erase that. So let's fix that. And these guys have to erase. So I'm going to have 4 plus 1 over 4, 5 plus 1 over 5, 6 plus 1 over 6, because that's staying the same while the numerator is adding 1 to it. So we'll have 4 thirds plus 5 fourths, 6 fifths, 7 sixths, and 8 sevenths is our last guy. And so if we add those all together, we'll get, if we write it as a fraction, it ends up being 853 over 140. And for me to enter that, I just used my calculator and I was writing like a fraction 4 thirds as like 4, and then there's a button that says like A, B, C, 3. So then it comes out as 4 with a little 3. That means 4 thirds. And then you just keep adding each of those terms. Okay, so that's my answer on that one. And we'll move on to C. So this one is not K. We have that index. It says I for our variable, and that I matches 2. So I know what I'm plugging into. And I'm going to plug a 2. And so that will be 2 times 2 minus 1. And then we're going to add, we'll plug a 3 in. And then we're going to add, we're going to be doing this all the way to 6. So 2 times 4 minus 1. And we have 2 times 5 minus 1. And then 2 times 6 minus 1. And it's adding all those terms together. So we have a 3 plus a 5, 8 minus 1, a 7, 10 minus 1 is 9. And I didn't write that correctly. That's 12 minus 1. Which will be 11. And these numbers should look really familiar. It's a sequence that starts at 3, and it's really adding 2 each time, you can see. And that should be familiar to something we did a while ago, but you can see that for every x that we put in there, we got another 2. And so that's why that should make sense to be a familiar sequence, and it's actually an arithmetic sequence. So then we're going to add up all of those terms together. And we're going to get a 35. All right, we have one more down here. Again, you should have been pausing this along the way. If you've been watching all of them, pause it and try this one on your own first. And so let's see, this one looks a little bit different actually. It has an N here, and our N is here, but also has an A. So I'm going to plug a 1 in, but only to the N. So this will be A with a little 1 next to it, plus A with a little 2, plus A with a little 3, and I'm going to keep doing this all the way till 10. So A with a little 4, A with a little 5, A with a little 6, A with a little 7, A 8, a 9, and a with a 10 on it. And if you remember, when we were talking about sequences, this was just a kind of fancy way to say the first term of my sequence, the second term of my sequence. And this goes all the way down to the last guy, which is actually going to be called the 10th term of our sequence. That's what that notation is for. And we're going to learn a little bit more about how this relates to sequences on the next video.